Now let us study the different types of relation based on a different way of classification. So in that, the first one is what is called as a reflexive relation here. A relation on set A is called reflexive relation if for every element denoted by lowercase a belonging to the set A, the pair A comma A is present in the relation. So if we consider an example of set A as shown here, it has three elements, say 1, 2 and 3. Now what the definition says is, if you take each element of the set, okay, so we take say element 1, and if we take the pair in which both the elements, that is first and second elements, are having the same value of that element, so that means 1 comma 1 is the pair. Now this pair should be present in the relation, and all such pairs formed from all the elements of the set should be present in the relation. So therefore, with the remaining elements 2 and 3, we can see that their corresponding pairs 2, 2 and 3, 3 are also present in the relation. Therefore, as per the definition, this relation is a reflexive relation. Right? Now let us go ahead to the next type, that is called as symmetric relation. A relation on set A is called symmetric relation if for some pair A comma B present in the relation, the pair B comma A is also present in that relation, where A and B are elements belonging to set A. So here if we consider the same example of the set, that is A consisting of 1, 2 and 3, what the definition tells in simple words is that a particular pair, if it is present in the relation, then its reversed pair should also be present. That's it. Now here it's not mandatory that we should form all the possible ordered pairs from the elements of the given set. It just says that in the relation, whichever pairs are present, their opposite pairs, that is the reverse pairs, must also be present. That's it. So here if we see, one pair is 1, 2, as we can see here, the first pair. Now its reverse pair is 2, 1. Is that present in the relation? Yes, we see that it is also present. Now similarly, we have to confirm for all the pairs, that is 2, 3 and 3, 2 is also present. Now if we consider 1, 1, the reverse pair is the same pair itself. So therefore we see that for all the pairs, their reverse pairs are also present, or the symmetric pairs are also present in the relation. Therefore this relation is called as a symmetric relation. Now suppose, let us assume that suppose I add one pair, say 1, 3 in this relation, in this example, then will it be a symmetric relation? Although the symmetry of remaining pairs has already been checked, the answer is no, because for 1, 3 we also need its corresponding pair 3, 1 to be present. Only then that particular relation will be called as the symmetric relation. But if it is not, and we have only the pair 1, 3, then it will not be a symmetric relation. Alright, so based on the pairs which are existing in the relation, we check the symmetry and then decide whether it is symmetric or not. Let's move on to the third type, which is transitive relation. A relation on set A is called transitive relation if presence of pairs A, B and B, C in the relation implies that the pair A, C is also present in the relation, where A, B and C are elements belonging to set A. So what does this mean in simple words is that, we say in day-to-day life that, say, if A implies B and if B implies C, then A also implies C, right? So similar to that, we have this particular definition, that is, if we have some pair, say A, B present in the relation, and if we also have the pair B, C present in the relation, So you see which is the second element of the first pair, that becomes the first element of second pair. Now presence of both of these pairs in the relation, whether it implies that the pair formed by first and the last, that is from A to C, whether this pair is also present in the relation. If yes, then the relation is called as transitive relation. If not, then it is not transitive. So as an example, let us see the relation given here, that is we have the pair as 1, 2 and 2, 3. So by analogy we can say that this is A, B and the second pair is B, C. So we must search whether the pair A, C is also present in the relation, which is 1, 3, and we see that yes, it is already present. So therefore this particular given relation is a transitive relation. Now once again, like symmetric relation, here it's not necessary that you should form all the possible pairs from the given set and then check this transitivity. It is only based on the existing pairs given in the relation. Now once again, suppose we consider say an additional pair. Suppose in addition to these three pairs, suppose we had something like say 3, 3 as additional pair, and now we want to check whether this relation is still transitive or no. Now here we observe closely that suppose we have some pair, say for example 1, 3 and 3, 3, then it forms the pair 1, 3 which is already present. Alright, so therefore here there is no problem for the relation. So therefore the relation is still a transitive relation. You can take any other pair also, that is say 2, 3 is present and 3, 3 is present. So therefore 2, 3 which is still the same pair. Alright, so it's based on the given example whether the relation is transitive or not. And lastly we go to the fourth type of the relation, which is called as equivalence relation. If a relation on set A is reflexive, symmetric and transitive, then it is called as equivalence relation. So there are some examples of relations which might be simultaneously reflexive, symmetric as well as transitive, all the three. If that is the case, then that relation is called as equivalence relation.